Anjali Sheel, and I'm currently working as SD2 at Microsoft. And I have 5+ years of experience, and I'm an educator at 3 level by Unacademy. Today's topic is data link layer. I'll be mirroring my screen and then we will start our topic. So let's get started. So our topic is data link layer. Alright, so when we are going to be talking about the data link layer, what and all things we are going to be having. So you must have seen your OSI model, right? So when we talk about the data link layer, so this one is going to be the second layer of your OSI reference model. So we can say second layer of OSI reference model. Alright. Now when we are going to be talking about your data link layer, so what this layer is actually going to be doing, so this one is going to be the most complicated layer, and this one actually has a lot of complex functionalities and some of your liabilities. So your data link layer actually hides the details of the underlying hardware, like it is not going to be telling what kind of hardware it is going to be there, and it is going to be representing itself to the upper layer as the medium to communicate. Also, when we are going to be talking about your data link layer, so this one is going to be working between your two hosts, so which is going to be directly connected in some sense. This direct communication can be your point to point, or it can be on the broadcast level. So your systems on your broadcast network are actually said to be on your same network link, and the work of your data link layer actually gets more complex when we go where we will be dealing with the multiple hosts on the single collision domain. Your data link layer is actually responsible for converting your data streams to a signal bit by bit, and also it is going to be sending over the underlying hardware. And when we are going to be at your receiving end, so in that particular time, your data link layer is going to be picking the data from the hardware, which is going to be there in the form of your electrical signals, and then it is going to be assembling them in a recognizable format, and then it is going to be handling it over to the upper layer. Now when we are going to be talking about the functionalities of the data link layer, so let's just write about it. Functionalities of data link layer. So what and all functionalities this one is going to be offering? So the first one which it has is framing. So now I will be telling you what this framing is going to be all about. So when we are going to be talking about your data link layer, so your data link layer takes the packets from your network layer and then it encapsulates them into different frames. Then what happens? It is going to be sending each frame bit by bit on the hardware, and when we are going to be there on your receiver end, then your data link is going to be picking up the signals from your hardware and then it is going to be assembling them into the frames. So all that is actually going to be there in the part of your framing. The next one which we have is going to be your addressing. So when we talk about addressing, what and all we do in that, so your data link layer is going to be providing the two hardware, it is going to be providing your layer 2 hardware addressing mechanism. And here when we are going to be talking about your hardware layer, so that is going to be unique on the link, and it is also going to be encoding into the hardware at the time of manufacturing. So all that we are going to be taking care inside your addressing. The next one which we have is going to be your synchronization. So when we talk about the synchronization, what happens whenever we are going to be having some of your data frames, so that one we are going to be sending on your link. So what will happen? Both your machines should be synchronized in order to transfer all those packets. So all these are actually going to be the functionalities. Apart from that, what and all we will be having. So the next one is going to be your error control. So this one is going to be ensuring that whatever packets you are going to be sending are actually going to be error free. So what we will do, like there are going to be certain of the situations where we will encounter some of the problems at the time of transmitting the packet from one end to the another one. Some of the times even whatever the bits of the data which you are sending, they may get actually flipped. So because of that, error is going to get generated. So all those errors are going to get detected at your data link layer, and then it will actually make some of the attempts to recover the actual data bits. And this one is also going to be providing some error reporting mechanism to the sender. With the help of that, sender will actually understand that some error has happened so that it can actually troubleshoot it in that time. The next one which we will be having here is going to be your flow control. So when we are going to be talking about the flow control, so in that one, what will happen? We are going to be having some of the stations. So if you're going to have some of the stations on the same link, they can actually have the different speed or the capacity. So a data link layer actually ensures that whatever flow you are going to be having at both of the ends, your sender machine end and at your receiving machine end, so they are going to be getting exchanged on the same speed. And the next one which we will be having is going to be your multi-access. So when we are going to be talking about the multi-access, so what happens, when the host on the shared network is actually trying to transfer the data, so there is going to be the probability that we will actually encounter the collision. So what happens, your data link layer provides some of the mechanism which is like CSMA CD, and with the help of that, what happens, it actually provides the capability of accessing a shared media among multiple systems, and based upon that we can actually say that we are providing the multiple access on various machines. Now we are going to be discussing about your error detection and correction to more depth. So error detection and correction. So what happens, there are going to be various reasons. Some of the times it can be about the noise or it can be about the crosstalk. So what is actually going to happen, because of all those factors, there is going to get some of the situation which may help the data to get corrupted at the time of transmitting it. So what will happen, whatever your upper layers are going to be there, so those ones are actually going to be seeing that how your network architecture is going to be there, and they are not going to be actually aware about the hardware, because the data link layer is actually not going to be providing the such of the information. So what will happen in such a case, your upper layers are actually going to be expecting some error-free transmissions between the systems, and most of the applications will not function expectedly if they are going to be receiving the erroneous data. So what will happen, so the applications which are something like your voice or video, so they are not going to get affected with some errors, and they are still going to be functioning well. So what happens in such a case, a data link layer use some of the error control mechanism, which is going to be ensuring that whatever frames you are going to be sending, like your data bit streams, I can mention your data bit streams, are actually transmitted with some level of accuracy. So when we are going to be sending it, we are actually going to be considering the accuracy there. But when we are going to be understanding about this, we will see how the errors are going to be controlled, because it is actually very important to understand what kind of errors which can actually occur. All right, now we are going to be discussing about what and all types of the different errors which we have. Okay, so the first one which we will be having is going to be your single bit error. All right, so what will happen, let us say you are sending a data from your sender to your receiver. Everything remains same, only one bit gets corrupted. So that one is going to come as your single bit error. So let us say we have some data 0, 1, 1, 1. So let us say this is your sent data. When you are going to be at your receiving side, so let us say this is your received data. So here let us say you are getting this. So if you will see, this particular one got changed. So this one is going to be coming in your single bit error, because error is only going to be there at one place. The next one which we will be having will be your multiple bits error. So what will happen, let us say we have some of your sent data and some of your received data. So let us say the sent data was something like this, and the received one, let us say it became like this. So if you will see, two of your bits actually got changed. Not necessarily they should be in the same order, it can be available at any of the order. So in such a case, we say that this one is going to be a multiple bits error. Why? Because in this one, more than one bit is actually there in the corrupted state. The next one which we will be having here is going to be your burst error. So what happens in the burst error, so whatever your frame is going to be there, so that one is going to be having more than one consecutive bytes which are corrupted. So for that, what I will do, let me just take it and erase this. Yeah, so here what we will be doing, let me just erase all this data, like let me just change it to some like this. So if you will see here, this bit is different, this bit is different, remaining are same, but they are not consecutive, because when we are going to be talking about the burst error, so here consecutive bits will have error. All right, so here let us say we have your sent data, we have your received data. So let us say your sent data was something like this, and the received data was something like this. So here if you will see, these three, all the consecutive ones are having data. So in such a case, we say this is going to be the burst one. Why? Because they are consecutive. The next one which we are going to be having is going to be your types of errors. So let's discuss about the types of errors which we have here. All right, so when we are going to be talking about the error, so you know, for your error control mechanism, we can have two possible ways. So the first one is going to be your error detection, and the another one is going to be your error correction. So we can say two possible ways for your error control mechanism. Two possible ways for error control mechanism. What and all those ways are there? Firstly, you should be able to detect your error. That is going to be coming in your error detection. And the second one is going to be how you are going to be correcting your error. So that is going to be coming in your error correction. So these are going to be the two possible ways with the help of which we actually address it. Now let's talk about error detection. So what happens in the error detection? So you know, we are going to be having some of your frames. So when we are going to be talking about all those frames, so those ones are going to be get detected by the means of parity check. And also we are going to be performing some cyclic redundancy check there. So in both of the cases, few extra bits are sent along with the actual data to confirm the bits received at the other end are same as they were sent or not. If the counter check at the receiver end fails, the bits are considered as corrupted. And when we're going to be talking about the parity check, so what actually we do in such a case, we are going to be sending one extra bit along with your original bits. And how that is actually going to be helpful, so that extra bit is actually going to be making the number of ones either even in the case of even parity, or if it is going to be the odd parity, so it is going to be making number of ones as odd. So what will happen, the sender, when we are going to be creating a frame, it is going to be counting how many numbers do we have in that. For example, if even parity is used, so the number of ones is going to be even, then one bit with the value 0 is going to be added. But if it is going to be your even, so what we will be doing, we are going to be like, since your number of ones is going to be odd, so in order to make it an even bit, what we will be doing, we are going to be adding one extra one to it. So what you can actually consider, like I'll be talking about it for your parity bit. So what we will be doing in this case, one thing which you will have to consider, that if you have an even parity, so in such a case, we are going to be adding the extra bit as 0. So extra bit added will be 0. But if we are going to be considering the odd parity, so the extra bit which we will be adding will be 1. So extra bit added will be 1. Because in such a case, we are going to be targeting on making them even out. All right. So in this particular one, what actually happens, so whatever the receiver is going to be there, so that is going to be how many number of ones are we having in that frame. If the count of ones is even, or if you are using the even parity, so what will happen, whatever the frame you are going to be considering, so that is not going to be corrupted, and we will say it is the acceptable one. But if the count of your one is odd, so what we will do, we will say that okay, your odd parity is used and the frame is still not corrupted. But what if your single bit actually flips in the transmission, so what will happen, the receiver will detect it by counting the number of ones. But when more than one bits are erroneous, in such a case it will be difficult for them to detect it. So it is going to be helpful only when you are having the single bit of error, but for the other one it is not going to be that helpful. Now the second one which we have is your cyclic redundancy check, which is also known as CRC. So your cyclic redundancy check. So what we actually do in your cyclic redundancy check, so this one is a very different approach if we are going to be detecting the error, if the received frames contain the valid data or not. So what we do in this technique, so this one involves a binary division of the data bits which are being sent. So whatever your divisor is going to be there, so that one we are going to be generating using the polynomials, and the sender is going to be performing some of your division operations on the bits which we are sending, and it is also going to be calculating the remainder there. So before we send the actual bits, whatever your sender is going to be there, it is going to be adding some of the remainder at the end of the actual bits, and actual bits plus the remainder is actually called as the code word. So what is the code word here? We can say your code word is actually your actual data bits, and along with that we are going to be adding the remainder. So this is what your code word is going to be there. So when we are going to be talking about the sender, so that sender is going to be sending data bits in the form of your code words. All right, so that is how it is going to be working. And if we are going to be talking about a cyclic redundancy check, what will happen? Your receiver is going to be performing a division operation on your code words by using the same CRC divisor. If your remainder contains all the zeros, then your data bits are actually accepted. Otherwise, we say that some of your data is actually corrupted when we were trying to transfer it. Now we are going to be talking about your error correction. So we are having two types of error corrections available. So when we are going to be talking about the error correction, so we can actually perform it in two ways. So one is going to be a forward error correction, and the another one is going to be a backward error correction. So backward error correction and forward error correction. Now let's discuss about what and all these two things are going to be there. So we are actually in your digital world, so where you can actually perform the error correction in two of your ways. So the first one is going to be your backward error correction. So what happens in this case, when your receiver receives some of your data and that is going to be having some of your error, so what happens, it is going to be requesting the sender to retransmit the data. And what happens in your forward error correction, so let us say a receiver is detecting some error in the data received. What it will do, it is going to be executing the error correcting code, and with the help of that it is going to be auto recovering it, and what it will do, it is going to be correcting it the sometimes of errors which your data is going to be containing. Now when we are going to be talking about which is simpler out of these two, so your backward is the simpler because it is just straightforward asking to retransmit the data required, and this one is also very efficient to use whenever retransmission is not going to be expensive. But when that one is going to be expensive, in such a case we will have to go ahead and use the forward error correction. All right, and whenever you will have to correct the data in your data frame, in such a case the receiver must be knowing exactly which bit in the frame is corrupted, and in order to locate that bit in the error, your redundancy bits are going to be used as your parity bit for your error detection. And if like with the help of that, if you are able to generate the error, it is good. Otherwise you will actually go ahead and use the some other error technique in such a case. Now I'm going to be talking about some data link control and protocols. All right, so what is actually going to be there as a part of this. So we are going to be discussing about what and all controls and protocols we have in our data link. So the first one which we are going to be having is going to be your flow control. All right, so your data link layer is actually responsible for implementing the point-to-point flow and error control mechanism. So let us say you are having a data frame, and that data frame you are sending from one host to the another one by using a single medium. So whenever we are going to be performing it, so it is going to be required that your sender and receiver should work at the same speed. So when your sender is going to be sending it on some speed which the receiver can process and accept the data, then it is okay. But if the speeds are not going to be the matching ones, in such let us say your sender is actually sending the data at a very fast pace, then receiver will be overloaded, and in such a case some of your data will get lost. So for this particular one, it should actually be performing it at the same speed. For different speed, data will get lost. All right, now let us discuss about the two mechanisms through which we can actually control the flow of our data. So, mechanisms to control the flow. So the first one which we will be having will be your stop and wait. So in this particular one, what is going to happen? So we are going to be having a sender, and here we will be having a receiver. So when these things are going to be there, so firstly your data is going to be going to your receiver. So let us say we are sending a frame 0. Once it is getting received, your receiver is going to be sending a acknowledgement for the same. Similarly, your sender is going to be sending another frame. Let us say you have your frame 1. Then it is going to be acknowledging that I have received it, and here you will be receiving the acknowledgement. If in any of the case you are not receiving the acknowledgement, that means your data was lost, and in such a case your sender is going to be resending that data. So when we are going to be considering it in this case, you are actually stopping and waiting for the acknowledgement to get received. That is the reason it is actually known as stop and wait. The another one which we have here is your sliding window mechanism. So when we are going to be talking about the sliding window mechanism, so what will happen? Both of your things, your sender as well as the receiver, they are going to be agreeing on some number of data frames. That okay, let's agree you are going to be sending this one. So what they will do, they are going to be waiting for those particular number of frames, after which they are going to be sending the acknowledgement. So what was happening in your stop and wait? We were actually wasting a lot of resources. Why? Because for every frame we were sending the acknowledgement, but what we are doing in the case of your sliding window, so you are actually going to be waiting for some of your data frames to get accepted. So you can consider this is how your data is going to be there. So what sliding window mechanism does, let us say this is how your sliding window is going to be there. Let us say they agreed for 2. So once these 2 are there, they will be sending the acknowledgement. After that, this sliding window is actually going to be moving ahead in the stream of your data, and with the help of that it is going to be detecting if some error is going to be there or not. So in this particular one, when the data frame is transmitted, so there is going to be the possibility that the data frame which you have sent, that must have lost in the transmission, or if you have received it, you must have received it in the corrupted form. So in both of the cases, your receiver is not going to be receiving the correct data frame, and sender will actually not know about any of the loss. So in such a case, both your sender and receiver are going to be equipped with some of the protocols which is going to be helping them in detecting transmit errors such as your loss of data frames. And but you can understand in this particular one that either the sender retransmits the data frame, or your receiver will have to request to send the frame again. Now we are going to be discussing about what and all are the requirements for your error control mechanism. So requirements for error control mechanism. So the first one which we will be having is going to be like we are going to be having various requirements, and the first one which we will be having is going to be your error detection. So in this one, what we will have, we are going to be having a sender and a receiver, and either both or any of them are going to be are not going to be certain about if there is some error in the transmission. Then we are going to be having something as positive ACK. So what does it mean? It means positive acknowledgement. So when the receiver is going to be receiving the correct frame, it is going to be acknowledging it. Similarly, we are going to be having something as negative acknowledgement as well. So what does negative acknowledgement mean? So when the receiver is receiving a damaged frame or a duplicate frame, in such a case, it is going to be sending a negative acknowledgement back to the sender, and sender will understand that they have to resend the correct frame. The last one which we have is going to be a retransmission. So what do we mean by the retransmission? So the sender is actually going to be maintaining a clock, and it is going to be sending a timeout period. So if the acknowledgement of the data frame previously transmitted does not arise before the timeout, in such a case, the sender retransmits the frame, thinking that the frame or the acknowledgement are both are in the loss. So what it is actually going to be doing, it is going to be waiting for some definite period. Once the timeout happens, then it is going to be sending it again. So the three types of techniques which are available on the data link layer may deploy to control the errors by automatic repeat request. So what it is doing, it is taking care about the data and it is sending the request on its own. So now we are going to be performing the same using your stop and wait. So this is your stop and wait automatic repeat request. So in such a case, what will happen? You will be having your sender, you will be having your receiver. So it is going to be sending a frame. So let us say you are sending a frame. So for that you are getting an acknowledgement for the same. So here you are going to be doing also some timeout is going to be happening. Let us say in that timeout you are not receiving the acknowledgement. In such a case, it will say that you have to send that packet again. So let us say you are sending a frame 1. And after that your timeout is happening, but you haven't received the acknowledgement for the same. So what you will do, you are going to be sending your frame 1 again, and let us say in such a case you have received the acknowledgement. So that is how it is going to be working. So automatically it is going to be sending it again and again. So in this particular case, what happens, your sender is going to be maintaining a timeout counter. So when a frame is sent, the sender starts the timeout counter. If the acknowledgement of the frame comes in the time, the sender transmits the next frame in the queue. If the acknowledgement does not come in the time, your sender is going to assume that either the frame or its acknowledgement is lost in the transit, and your sender is actually going to be retransmitting the frame, and it is going to be starting your timeout counter. And if you are going to be receiving a negative acknowledgement, in such a case, the sender is going to be resending the packet. All right. Similarly, we are having one more, that is going to be your go back and automatic request timeout. So in this particular one, what happens here, you are going to be using your stop and wait automatic request control mechanism, and let us say that one is not utilizing the resources at the best. So what we will be doing, we are going to be using go back and automatic request. So what we will be doing, it is going to be same as the previous one, but what will happen, so earlier what we were doing, for every packet we were having a timeout, but in this case what we will do, we are going to be, meanwhile it is going to be sending the transmission, like we are going to be increasing the window for our timeout, and when your acknowledgement is not going to be there, so in such a case we are not going to be keeping our sender idle. It will keep on sending the packets, and we are going to be working in maintaining a window for the same. So what is going to happen, let us say you are sending a frame 0. Meanwhile, I'm not going to be waiting for it to send the acknowledgement. So let us say at this particular time it is sending the acknowledgement. So you can see for this particular time your sender was idle. So what we will do, instead of keeping it idle, we will keep on sending more frames, and instead of having the individual timeouts, but like instead of having only one timeout, what we will do, we will be having individual timeout. So once you are receiving it, so for this particular one we are going to be stopping the timeout for the same, and let us say after this you are receiving the acknowledgement for your frame 2. So it will say, okay, this one timer is still running, and we have received a timeout. Still we have not received the acknowledgement, so you have to send that packet again. But if you will be looking at the F2, so for F2 we have received the acknowledgement. So with the help of this, you can understand how does it is going to be working. So in this one, your sending window size is going to be enabling the sender to send multiple frames without receiving the acknowledgement of the previous one, and the receiving window is going to be enabling the receiver to receive the multiple frames, and it is going to be acknowledging them. And your receiver is going to be keeping a track of your incoming frames with the help of the sequence number. So when your sender is going to be sending all the frames in the window, it is going to be checking about what sequence number it has received the positive acknowledgement. If all the frames are positively acknowledged, in such a case, the sender is going to be sending the next set of frames. If the sender is going to find out that it has received a negative acknowledgement, or it has not received any acknowledgement for a particular frame, in such a case it retransmits the frame, after which it does not receive any of the positive acknowledgement. After this, we are having something as selective repeat automatic request control. So selective repeat automatic request control. So in this particular case, what we will be doing, we are going to be having a sender, we are going to be having a receiver. So this one, like when we were talking about the go back N automatic request control, what was happening, we were assuming that the receiver is not going to be having any buffer space for the window size, and it has to process each of the frame as it is going to be coming. So that one was actually enforcing the sender to retransmit all your frames which are not acknowledged. But when we are going to be talking about the selective repeat automatic request control, so what will happen, your receiver, while keeping the track of the sequence number, it is also going to be buffering the frames in your memory, and it is going to be sending a negative acknowledgement only from the frames which is missing or damaged. So what is going to happen, instead of like, let us say you are sending some frame, you are receiving an acknowledgement for the same. So instead of keeping a track for each and everything, what we will do, we are going to be having a track at this level and a track at this level. So what we will do, we are going to be seeing, okay, some frame is there, some acknowledgement is there, probably some frame 1 is also there for which we didn't receive any of the acknowledgement. So what it will do, at the end it is just going to be checking that for which and all you have not yet received the acknowledgement. So in the selective repeat ARQ, your receiver, while keeping the track of the sequence number, it is also going to be buffering the frames in the memory, and it is going to be sending a negative acknowledgement for only those frames which are going to be missing or damaged. So the receiver in that case is going to be receiving only those packets for which you are going to be receiving a negative acknowledgement. So that is how your selective repeat automatic request control is going to be working. So that's all we were having for your data link layer. I hope you were able to find it interesting. Now we are going to be meeting in our next class. Till then, happy learning. Bye bye.